So today we'll actually talk about how to program. So this may be one of the most important ones of the semester because we're actually diving into how do you create your first Java program. And if you've looked it up, typically the first program you create is something called the Hello World program. So we'll talk about how to create that and where do we go from there. So in this class, we're using a programming language called Java. All right. Java is a fairly um, well-known language. It's one of the most popular, if not the most popular. And it's been around for a couple of years, I think 30 or 40 years. It has a lot of good things to it, but one of the biggest benefits of Java is just its ability for teaching purposes, right? Although it's good for teaching, but it's also good as just a standard language as well. A lot of things run off of Java. If you have an Android phone, every single program or app on that phone is written in Java. Well, they've changed it a little bit now. They're using something called Go because of money. But for the most part, the majority of the apps you use on an Android phone are written in Java. For Apple, apps are written in either Objective-C or Swift, which is very similar to Java. So if you're interested in app development, specifically Android, you should learn Java. If you're interested in app development for iPhones, Swift and Objective-C are probably the way to go. However, the concepts we learn in this class can be applied to Swift Objective-C. Now, there are many different languages out there. For example, my main programming language is Python. Python is a little bit different than Java, a little bit less stringent and a little bit more lightweight. And you'll see what I'm talking about once you start learning different languages. But Java is really good. This is the first language I learned. It's a really good foundational language to know, and I actually still code in Java. All right, so Java is simple. Compared to what programming languages used to be, it's fairly human readable. It's a general purpose programming language, meaning that you can use it and code many different programs, right? All types of different programs. A lot of programs that you use today are probably written in Java. JavaScript, on the other hand, is a popular internet programming language derived from Java. Although JavaScript has become more well-known and more general purpose, originally it was for websites and things of that nature. The computer science website or the class website, I use a lot of JavaScript. Very similar to Java, except JavaScript is something called interpreted. So when you run JavaScript, it's interpreted at runtime. However, Java is something, it's compiled. So before you can run it, you have to compile it, which optimizes your code for your computer. So you may come across something called C++ as well. C++ is basically the precursor to Java, right? Java was based on C++. A lot of the syntax or the wording that you use in Java is similar to C++. However, C++ was designed for systems and applications programming, extending the C language. Java was initially created as an interpreter for printing systems, but grew to support network computing. Java has become a lot more popular beyond just its initial use. However, C++ is still a very, very powerful language. So Microsoft Windows, most of Microsoft Windows is written in C++. Most of Mac OS is written in C++. Even Facebook is written in C++ for the most part, right? A lot of different languages go into large systems like that, but C++ serves as the foundation for a lot of those as well. History developed by some guy at Sun Microsystems, James Gosling, later merged into Oracle Corporation. So if you hear about Oracle, they're the ones who own Java. And that's why I was talking about Google is moving away from Java for Android because Oracle wants money and Google don't want to pay them. Derive much syntax from C and C++, promise to write once and run everywhere. So that's a key word, something we'll talk about a little bit more. So if you go back to the lab, if you were able to install Java, I know those of you on Chromebooks weren't able to install Java. But if you were able to install Java, there are a couple different editions of Java. You have the Java Standard Edition, which is basically used by applications, right? You have the Java Enterprise Edition, which is used to develop server-side applications. You have the Java Micro Editions, which is just a small environment for mobile app development. In this class, if you were able to, we use the Java Standard Edition. We don't need anything extra. It has all the libraries and utilities that we need, so we use the Java Standard Edition. So you look right here, this is a standard Java program. It looks very boring, but this is basically what Java looks like. So the first thing we have to do is declare our class. So we always need a class, regardless. If you have a file, inside that file, you need a class. And then any Java program, it doesn't matter which class it's in, but you need at least one main method, right? So your class is your class corresponds to a file. Your main method corresponds to your entire program, right? Your entire software. So your software can be composed of many different files, but you need at least one main. So when you run your program, the first lines of code that are run are inside your main, all right? And then you have your statements, your code statements. So in this one, we're printing to the console, system.out.println, welcome to Java. And that prints to the console. And I'll show you what this looks like in a real program. So I'm using something called the Java Visualizer, and you guys can work along with me so that you can get experience. But basically, this works, and that when I write it, you can immediately visualize what I'm writing. So again, the first thing we need is a class, public class, I'm gonna say lecture 5. Inside that class, or whichever class inside your software, you need a main method. So public static void main string args. Do note, for each one of these, we need an opening bracket. And there will be a corresponding closing bracket for these as well. Then I'm going to do my print statement, system.out.println. I'm going to say hello world. Then I need a closing bracket for this one, and then a closing bracket for my class. You have to close your main method and close your class. And notice this first line is inside my main method, right? And basically this program is going to print to the console. That's why I use system.out println. I'm printing out to the console. Later on, we'll use something called system.in, which means that you're going to read in from the console. So I could type something in the console and then read it in. So we create our class, we create our main, we go to the first line. Again, any program, the first line that's going to be executed when you run your program will be the first line inside your main method. So we run that, and it prints out to the console. And our program ends. That's it. All right, that's it. If I do this in JGrasp, which is what you all downloaded and installed, you could do the same thing in JGrasp. So let me exit out of this. Let me create a brand new file, new Java. Say public, let me zoom in for you. Public class lecture 5. All right. We need a main, public static void main string args. And then we have our actual coding statements. So system.out.println hello world. All right. I could put more lines down here. So system.out.println. This is Java. System.out.println. We learning something. whatever we want to do. We're just printing out to the console. I do need a closing bracket and another closing bracket for my class. So this program is going to run, hello world, this is Java, we learning something, okay? So the first thing, if you remember what I was saying, the first thing we have to do is compile our program, which is this little green plus symbol. We compile it, it says to save it. When you save your file, it must correspond to whatever class you have in this file. So this file has class lecture 5. So I must save this as lecture5.java, and it fills it in for me. So you see now right down here, it's compiling, and the operation is complete. Then to run it, you click on this little red running man. And you see it says, hello world, this is Java, we learning something, right? And this console is similar to a command line. So if I ran my program from the command line, you would see, hello world, this is Java, we learning something. That's what this console is, right? So right now, we just create our first command line program, okay? So like I said, when you write your code, you must compile your program. And what happens is, it's converting that code that you wrote into bytecode that the computer can understand. And typically with C++, when you compile a program, it compiles it into machine readable code and the machine runs it. However, in Java, we have something called the Java virtual machine, which sits in between you and your actual physical hardware. And so when you compile a Java program, it converts your code into that Java virtual machine readable code, right? Not necessarily the physical machine code. So this is what I'm talking about. So you have your source code, which is your program. You compile it into bytecode. That bytecode is then run on the Java virtual machine. The Java virtual machine runs on top of whatever operating system you have, just like I was talking about last week, virtual machines. It runs on top of your operating system. So if you think about Android, Android has the Linux operating system and then the Java virtual machine on top of it, and then we run all of our little apps on top of that, right? And so that's important. That virtual machine is important because now your code, all it has to do is be converted into Java virtual machine code. And that's it. You can run it on whatever machine as long as that physical machine has the JVM installed, Java Virtual Machine. However, with C++, if I wanted to run my program on Windows, Linux, and Mac, I would have to compile it for each one of those individual computers. And when you compile it, it not only compiles it for that specific computer, it compiles it for the hardware that's being used. So if you have an Intel processor, if you have 8 gigs of memory, whatever, it compiles it for that architecture as well. Whereas the JVM, it removes all that extra stuff. All you have to do is compile your program once for the JVM, and the JVM runs on whatever computer, okay? So if you think about that intuitively, that means the JVM, instead of your program, the JVM is compiled for each different architecture, right? Your program is just compiled for the JVM. It's kind of a general architecture, if you will, right? So that's one of the benefits of Java. You write once, and you can run it on whatever computer has the JVM installed on it. Oh, just a second. All right. So what are the components of a program? So there are several different components of a program. We have comments, we have keywords, modifiers, statements, blocks, classes, methods, and the main method, okay? A lot of different elements, and as we go throughout this class, we'll cover each of these elements for the most part. So comments, you have something called line comments, block comments, java.comments. This is an example of a line comment. You use the double forward slash. This is the example of a block comment, / asterisk, and then you have your whatever you want to say, then asterisk / to close it. Then you have Java.comments. Java.comments are a little bit different. There's a program called the Java Doc Generator. It'll basically analyze all your code and pull out all of these Java.comments and put it into a file for whoever's coming along later. And comments are important when you code because, say for example, you're coding for a large institution, a large organization. Somebody coming along after you wants to know what you're doing, right? They don't want to sit here and try and read through all your code because coding is like writing. It can get very unique. So I would put a comment right here and say, I'm printing hello world to the console. Comments are not executed. They're not Java code per se, but you can kind of explain what you're doing. And as your programs get more complex, comments become more and more important. So again, this is a line comment. I can do a block comment like this. Anything under this comment, anything under there are now comments, and I close it like this, right? So I can put whatever I want inside here, and those are still going to be comments. Versus a line comment, I would have to put that double slash in front of each one of these. It only applies to one line. All right, so that's the difference. If you have multiple lines of comments, use a block. If you only have one line, use a line comment. And again, those aren't executed. We just skip over them. We go to our hello world. All right, we have keywords. So we have class is a keyword, public, static, void. Those are all keywords, right? So if we go back to our code, we have public as a keyword, class is a keyword. And we'll talk about those more in depth. I'm just going over the kind of the general structure. Public, static, void are keywords. In JGraphs, it highlights these in purple as keywords. Public, static, void. Those are all keywords. When it's green like this, that means it's a string. We'll talk about that later as well. All right, static, final, abstract, protected. These are all modifiers, public, private. Those are considered modifiers. They modify some type of data. They're also keywords. You see public, static, those are all modifiers, okay? Void, class are keywords. They do something else. So public means the class can be accessed by other programs or other classes within your program. Private means that only the class that you're in can access that data. And again, we'll talk about this in more depth later on, but just know these are some keywords that we'll talk about throughout the semester. A statement is a single line of code. So system.out.println, welcome to Java, is a statement. It's just one line of code. Each statement, be mindful of this, each statement ends with a semicolon. Right? Every single one ends with a semicolon. So you look back here, these two things are not statements. Right? My class, my main, they're not statements. However, this is a statement. As such, I must end it with a semicolon. Blocks. A pair of braces in a program forms a block that groups components of a program. So this is a block, right? From inside here, all the way up here, that's considered a block of code, right? So if we look here, public class welcome, public static void main. This is a class block, and that's a method block, right? This is our main method, and this is our class. Everything inside these two braces or brackets are inside of our class block. Everything inside these two brackets are inside of our method block or our main method block, right? And slow me down if I'm going too fast or ask questions if you have some. This is basic Java, and so it establishes a foundation for the rest of the semester. So if you have questions, let me know. We have our classes. In Java and with a lot of modern programming languages, they're considered object-oriented programming languages. Basically, what you have is you can have a class, and then you create an object of that class. A class is like a template. So for example, the example I like to use all the time because I love Mustangs is the spec sheet of a Mustang is the class. The physical Mustang that you can drive and whatever with is the object. So in Java, we create classes as our template, and then we create objects to actually use that template, right? We actually want to use and create a physical object that we can add those attributes to. So for example, a Mustang spec sheet, every car for the most part has make, model, VIN, right? That would be the spec sheet. That's our class would have make, model, VIN. When we actually create a Mustang object, the make would be Ford, the model would be Mustang, and the VIN would be whatever the VIN is, okay? So that's object-oriented program. We have classes, we have objects. Classes serve as a template. The object is the actual physical representation of that template. So here's an example of a class. Public class Mustang. We can have attributes, so color, year, make, model, VIN. This is a class. Then we create an actual object of that class using a new or the new keyword. So Mustang, my car equals new Mustang. That's called object instantiation or creation, right? We created an object. All right, so again, the class serves as the template. So this is our template. It'll have all these different variables in here. The object is the physical representation of that template. So now we can say my car dot make equals Chevy if I want. That doesn't make sense, but we can change those attributes as we see fit. So to show you that, I'm going to use this right here. Let me go back, edit code. So another major keyword of the main is static. Okay, that's a keyword. It's static in memory, meaning that anything we want to access from memory, from the main, must be static as well. Let's do public static Mustang. I'm sorry, class Mustang. So I create a Mustang class. And I'm going to copy this code right here and paste that in here. I don't need this. That doesn't make sense to Java. And we'll talk about this later in the semester. We don't just use variable. We have to say what type of variable they are. All right. I'll do that in a second. I'm just changing these because of the copy. It modifies the quotation marks. So I'm going to change these. Yada, yada, yada. Again, we do need a semicolon right there. The variable type for right now is going to be string. So don't worry about what that means. String, string, string. All right, cool. We have our class, which is our template. So now let's create an object of this template. And what I mean is the object is a physical representation of this template in memory. So Mustang, right, that's the type of object. My car equals new Mustang. And what you'll see is this my car will point to an object in memory. So we create it. It creates this, sets our template, and then it adds all of that to there. And down here, we have something called my car, and it points to this object, right? Again, classes are our templates. Objects are the physical representation. We actually have a physical object in memory. So that's the concept in object-oriented programming. And trust me, if none of that made sense to you, or it went right over your head, we're covering this all year long. And honestly, objects and classes, we don't cover in depth until programming 2. But I do want to give you just a brief introduction, okay? So if all of that went over your head, don't worry about it right now, because we won't do too much with it. All right, we also have something called methods. Methods allow you to organize your code or put code that you're going to use multiple times into a separate method so that you can just call it, okay? So for example, we have our Mustang, right? We have a red 2020 Ford Mustang. A friend asks what the VIN number is. You can get the VIN number from the vehicle itself, or you can get it from the spec sheet, right? So we have this physical representation of a Mustang, and we could say get VIN number. That's a method that would get the VIN number. So we have this class, this Mustang class. We create a method, public variable get VIN number, and it returns whatever our VIN number is, right? Which would be 1HGBH, whatever, right? We can call this method and get our VIN number. It'll return whatever our VIN number is. So if we look at this code, inside of our class, I can create a method, public string. Don't worry about the syntax right now. Get VIN. And I would say return VIN. That'll get us our VIN number. And with this method, I can call it using my system.out.println. I want to print it to the console, mycar.getVin. It'll use mycar object and call this method, returning whatever this VIN number, and I'm printing it to the console. And again, if this is going over your head, don't worry. We're going to break each part of this program down throughout the semester, okay? Don't worry like this is too much. We will go through all of this throughout the semester. So we create my car, which is a physical it's an object of Mustang, and it's our physical representation. Its color is red, its year is 2020, make is Ford, model Mustang, VIN is this right here. So now down here I call mycar.getVin. It's going to return this VIN number and print it to the console. See, it says mycar.getVin. It calls this method, returns the VIN number, which is all this right here, back down here, and then we print it to the console. So methods make it easy to access data, modify data, or organize your program. And in this class, we won't be doing much of this right here. We won't be doing much of that class object mess, but we will use methods in the future, okay? I just want to give you, again, a brief introduction to this. And I am recording this, so it'll be up on the class website and on the YouTube channel, all right? So that you can look through it. So again, we have our object and we have our method. All right, so we do have our main method. Like I said previously, our main method is the first line of code that will be accessed or run in your program. So inside your main method, this time I'm going to go to JGrasp. I have these 3 statements. It will run these 3 statements, system.out.println hello world. This is Java. We learning something sequentially. So it starts here, then goes here, then here. Right? And if I run this, again, hello world, this is Java, we're learning something. And I encourage all of you to, while I'm talking about this, code this on your computer. Code it in your browser or in JGrasp so you can get an idea of what I'm talking about. Because on Friday, we will do your first program, and it will be due. And then on Sunday, your first assignment will be due. So I encourage you all to be prepared for that, to write this while I'm talking about it, so that you can ask questions if you run into an error. Because if I do this right here, if I take off that semicolon, if If I compile it, I will get an error. It says error expected, semicolon, on this line, okay? So in case you run into an error, I encourage you to do this while I'm sitting here so that you get an idea of what I'm talking about. Like I was saying, your main method is the first method that is run in your program. Regardless of how many other methods you have, it will always start in your main method, okay? All right. All right, so let's look at this main method declaration. This program prints welcome to Java. This is our main method, public static void main string args. And that's it. That's it for today. That's your brief introduction to Java. All right, all of the different components. And again, as we go throughout the semester, if all of this went over your head, don't worry. As we go throughout the semester, I will cover each part in more detail and with more clarity, okay? I just want to give you all the tools to write your first program. And the beauty of programming is anything you see on a computer, somebody coded it. And there's something called open source software out there, which means you can get the software to some programs that you use, add your own modifications to it, and use it that way. So as you get better at programming, you know, you can make a computer pretty much do whatever you want. All right. For example, in my research, I'm building artificial intelligence through programs. Okay. And that's how it's done. And as you get better at it, you'll be able to do whatever you like as well. And hopefully in the future, when you all become, you know, master programmers, you make me look really good as your professor. Okay. And just know my teaching style, I will push you. I will push you all to be the best you can be because I want you all to compete with anybody out there. I want you all to compete with anybody from Duke, Harvard, whatever the school is. I want you all to be able to walk into a room and compete with them. So I will push you. I don't necessarily consider it to be difficult, but you do have to apply yourself. All right. All right, that's it for today. If y'all don't have any questions, I'm just gonna go ahead and end it right now. I will try to post this video, hopefully in the next couple of days. I got a lot on my plate right now, but I will try to post it here soon so that you can review it and start practicing because we will start using these techniques as we go throughout the semester. All right, I'll see you next time.